Well, one thing I think everybody here tonight would be very interested in hearing, since Hawaii has the highest electric rates of any state, San Diego Gas and Electric is substantially higher than the state of Hawaii. We would like to hear you talk a little bit about Kit Carson's rates, electric rates, and rate history.
So, electric rates are broken up primarily in New Mexico in two components, the power, cost of power, and the cost of distribution. So everything from the power supply to the big power stations, and then that's one cost, and then everything from the power station to your meter and to your plugs is a second cost. So the first thing, I've been the CEO of Kit Carson for 31 years. We've only had two distribution rate increases in 31 years. And so one was I believe 8%, and one was a 9%. And so, if you do your math, that's 16% over 31 years. We've kept the distribution side relatively stable. On the power side, a second reason Kit Carson left its power supplier is from 2000 to 2014, our rates doubled. Went up 100%, and so it was becoming unaffordable. Where 75% of our bill to our members was the cost of power, and so today we've been able to lower that to about 45%. The second thing is we've been able, through the board's direction, stabilize our power rate. So 45 to 50% of our bill is going to be fixed to 2040. With Guzman's contract, with the way we've negotiated our solar cost, half our members' bill won't change for 17 years. We're working on the distribution side. That's kind of the poles and transformers, all the stuff that you see in the roads, in the neighborhoods. We think that's going to increase, but that's going to increase slower. And it gives us some latitude because I have half your bill fixed. Today, when we paid off our contract exit to Guzman, or for Guzman to enter that contract and hit our solar goals, we reduced our wholesale power cost by 33%, and we've given all that money back to our members. About $18 million is what we give, about $1 million back a month to our members. Average retail residential rate, and it depends on summer, winter, is probably between 13 and 14 cents a kilowatt hour. And it was up at 18 and 19 cents. And so my goal here at the co-op is really to stabilize them. We always try to lower them. I don't think that's realistic with some of the other costs that are pushing or driving our costs, like insurances. We live in the forest. Getting insurance for wildfire issues is getting tougher and tougher. More members want our facilities underground. We have a lot of overhead construction here in northern New Mexico. But we've been able to stabilize rates and have some of the lowest rates in the Southwest. And half of that is going to be fixed for 17 years. So a very small portion of people's bills will be subject to increases over the next few years.
13 cents a kilowatt hour versus, I think, SDG&E is at an average of 48. So what are some of the plans for the future for Kit Carson Electric Co-op?
That's a good question. We're going to continue to build more solar. Under our contract with Guzman, a couple things. We want to enable, we have two pueblos, and they are really talking about more sovereignty issues. and energy sovereignty is one of them. So we're working with them to see how we can help them supply more of their energy, be more self-sustaining. So we have relationships with our two pueblos, Taos and Picaris Pueblo, both which we have projects to build solar and batteries, both to serve the pueblos, but then the excess to serve the members. So we have a couple of solar and battery projects we're currently working on. We're looking now, guys, on more distributed batteries, so we can put more batteries out into the system, both for resilience and for reliability, so that if we do have wildfire issues or just need extreme weather, we have batteries from 2 to 4 hours that can help keep critical infrastructure operating while the lawmakers and first responders decide what course of action to take for that event. We're also building 3 microgrids for wildfire mitigation at some of our mountain towns, where we actually will have solar and storage. They'll be monitoring. We're going to introduce AI into our architecture, so that kind of real simple, have a bunch of cameras looking at the forest and kind of learning what is a start of a fire. And with the intelligence, the whole scheme is to be able to turn on a microgrid, shut the power line down so there's no issue with the power line from extreme weather, give people, citizens, a chance to figure out what's going on, but still have power, communications, water, everything you need. And so we have 3 of those that we just recently got a grant from the DOE to build. And if that's successful, we want to build more microgrids so we can separate different parts of our system for different reasons. And then we're really looking right now at long duration storage. Batteries, right now, I think the best you can get from a utility size battery is 4 to 6 hours. Here in northern New Mexico, when we do get a lot of snow. When you have 2 or 3 days of snowy days, 4-hour battery doesn't handle it. So we're looking at green hydrogen. Green hydrogen is looking at reclaimed or effluent water from wastewater treatment plants. So we want to reuse water that people would otherwise not use, except probably golf courses. Clean it to a level of purity that is needed for the process. Use solar power to separate the water to hydrogen and oxygen, and then store it. And then when we need it, run it through a fuel cell, so there's no emissions. And then the fuel cell will generate electricity when we need the electricity, and then create that cycle. So we have 2 municipalities, a mine that has a cavern full of contaminated water, and we want to build another 60 megawatts of solar to drive this green hydrogen process, and have battery storage for 24 to 48 hours. And so that, and right now we're actually writing a proposal to the federal government to get some financing. With that type of technology that I think is here, but hasn't been proven in a bigger scale, I do think you can get to 100% renewables in a responsible time with current technology that just needs to be refined. So those are our goals right now, and right now we're on target. By 2026, Kit Carson will probably be about 65 to 70% renewable, just with these solar and batteries we have outside of the hydrogen. If we were to get the hydrogen, we'd be close to 90% renewable by probably 2030. And so, again, pretty confident that we'll hit that first number. But we think a green hydrogen product could take us over the top to hit our renewable energy goals. And use non-potable water. There's a lot of wastewater treatment plants in our territory in the country that basically they just put it back into the ground or clean and put it back in rivers. And we're saying, why don't we just use that for energy? The byproduct of this process is water. So again, that's our future goals, and we already have either some started and some under some application review.
We need another set of data to explain this puzzle, which I could only find in one place. This chart comes from the Sacramento Municipal Utility District, known as SMUD. This chart compares two kinds of electric utilities. SMUD is a publicly owned utility, which makes it a nonprofit organization. This chart shows 5 publicly owned utilities from various regions of California. The Golden State also has 3 large investor-owned for-profit utilities, which also appear on the chart. This represents our tale of 2 utility types. We converted the chart into a bar chart to more clearly show the differences in the typical monthly bill for the 8 different California utilities. The chart shows the monthly average residential electric bill for a home using 750 kilowatt hours of electricity in a month. Clearly, the 3 investor-owned utilities in blue are significantly more expensive than the 5 publicly owned utilities shown in orange. SDG&E is far more expensive than the rest of the utilities. In fact, SDG&E is 2.5 times more expensive than the average of the publicly owned utilities. This is more than a budgetary issue. This difference affects our transition to a green economy. If we use the data provided by SMUD and divide the monthly bill by 750 kilowatt hours, we can convert the cost into a kilowatt hour rate. The result is a chart that shows that SDG&E's rate exceeds that of Hawaii, which is an island out in the middle of the Pacific Ocean. Southern California Edison and PG&E are not far behind,